For my demo, I created a centripetal force board. It was made up of a cardboard rectangle with a string tied to each corner. The strings were then tied together at a point equidistant from each corner above it that I could hold the string by and swing the board around in a circle.
There it is, a centripetal force board.
Here I am filling up a small cup of water. I put the cup of water on the centripetal force board in order to better demonstrate how centripetal force and acceleration affects an object.
So, I have a cup of water and my centripetal force board, and I'm gonna place the water on the board, and hopefully it won't come out when I spin it. That was pretty cool. Okay, so the centripetal force on the board is provided by the strings, which are pulling it inward when it's going in a circle. And the normal force of the board on the cup is the centripetal force on the cup. So the force is unbalanced because it's pushing the cup inwards, but there's nothing pushing the cup out. So that's the centripetal acceleration. So then when I spin it, the cup moves in a circle and the water doesn't come out because... So Newton's second law of motion states that an object in motion must stay in motion. And when the cup is moving in the circle, it's being moved in the direction of the circle, but at any given moment, its velocity is perpendicular to the radius of the circle. So if I were to put the cup on the board and then spin the board and let go, it looks like it's flying out. So that's why people say there's centrifugal force. But really it's just a lack of force because the centripetal acceleration is stopped. So the object will continue moving straight instead of moving in a circle.
So I created this diagram to better show how the centripetal force is acting upon the cup of water. In it, the blue arrows represent the velocity of the water at any given time. As you can see, they're straight arrows because of inertia, even though the next one is still a different direction. And that's because of the red lines, which are the centripetal force, which are causing the arrows to accelerate, because velocity is speed and direction, so acceleration can be a change of direction instead of a change in speed.
So I decided that that could have been more exciting. So now I have a bowl. I'm gonna fill this up with water. Oh, it's kind of paper, so hopefully it doesn't fall apart. But then I'm gonna put it on the board and we'll try this again. And I have to go to work soon, so hopefully I don't get really wet. Oh, it fell out. Okay. There's water on the board, that's what's coming out. So the water stays in the bowl because it wants to keep moving in the straight direction, but it's being pulled in by the centripetal acceleration. So hopefully, if I go fast enough and then I release it to my right, it will continue on the tangential velocity and then fall back down to Earth because of gravity. I think that was a success, and it was fun. So anyways, thank you for watching.